Okay, so what we're going to do today is we're going to take a look at a few problems with ratio. Let's take a look at the first one. So there are 32 students in a class and 12 of them are boys. The rest of them are girls. So let's find out how many girls we have in this class. So that's going to be 32 minus 12. So that's 20. So there are 20 girls and 12 boys. So let's look at part A. Part A wants us to find the ratio of boys to girls. So that's going to be boys to girls. So how many boys are there? 12. So that's going to be 12 to 20. Well, we can reduce this, right? This 12 and this 20 we can reduce because they're both divisible by 4. So if we divide the 12 by 4, I get 3. And if I divide the 20 by 4, I get 5. And so the ratio is 3 to 5. Okay? That's the ratio of boys to girls. So there are less girls, there are less boys than there are girls. Okay? Now, another way to take a look at this is to see what fraction of the class represent boys and what fraction of the class represent girls. To do that, I got to take a look at the total. 3 out of every 8, or 5 out of every 8 if I'm looking at the girls. So this 3 may be represented as 3 eighths, whereas this 5 may be represented as 5 eighths. So how did I get 8 there? I added the 3 and the 5. Right? So it's like I'm breaking this thing up into 8 parts. 3 parts boys, 5 parts girls. So we say 3 eighths and 5 eighths. So this is represented as a fraction. Let's get back to our problem. Then I look at part B. Part B says what is the ratio of girls to boys. This is different than part A. Part A was asking us for boys to girls. So girls to boys would look like this. Girls to boys, and girls we know 20, and boys you know is 12. And again, we can reduce this. This is 5 to 3. So 5 to 3 is the answer for part B. All right, let's take a look at a different question then. On a given test, there are 40 students, and the ratio of pass to fail is given as 4 to 1. So how many students pass the test? So the ratio of pass to fail is given as 4 to 1. So how many people pass? So basically, I'm looking to see what this 4 represents. And as we just learned, in fraction, this would represent 4/5. How did I get the 5? I add up the ratios. 4 and 1 is 5. So we're breaking this into 5 parts. 4 parts passed and 1 part failed. But we're only interested in the number of students that passed. So that's going to be 4/5 of whatever the total is. And in this case, the total is 40 students. Okay. So that's what I'm going to have to do. And when I do that, I'm going to end up with 32. 32 students passed. Okay. And all I did there was just a fraction, multiplication fraction. Okay. All right. So let's look at a different one. It takes more than 90 minutes to run 4 miles. At the same pace, how long will it take him to run 10 miles? So naturally, we think it's going to be longer. This is a direct proportion problem. Direct proportion, direct ratio. Okay. Direct. We're going to learn about indirect shortly. We're going to make a problem that is indirect. But for now, I can tell this is direct because I expect the number of minutes to increase with the number of miles. It only makes sense. It's going to take him longer to run more miles, right? So here's how I set this problem up. I say 90 minutes for 4 miles. Well, then I'm going to have X minutes because I don't know what X is for 10 miles. Now, right here, once I've set this up properly, it's very important that I do this. I have to now understand how to interpret this. So what I'm going to do now is I'm going to do what we call a cross multiply. Like so, and like so, right? It's a cross multiply. So in doing that, what I'm going to get is 4 times x is 4x is equal to 90 times 10. And so then if I finish this out, I'm going to get that x then is equal to 225. And if I forgot what I'm looking for, let's go back to the problem. This is minutes. Now, if you want to convert this to hours and minutes, that's fine. The problem really didn't ask us to do that. The time was given to us in minutes, so we're good. So this then is the answer to this problem. All right, let's take a look at another problem. It says 10 men build a pool in 3 days. How many men will it take to build the pool in 2 days? So we're talking about the same pool, right? And so 10 men build this pool in 3 days. Now, this is an example of an indirect ratio. Why? Why is it indirect? Well, if 10 men build a pool in 3 days, it's probably going to take more men to be finished with it earlier. How do I know it's earlier? Because the question is asking to build it in 2 days. So as one of these things decrease, which is the number of days, the other one will increase. The number of men it will take will have to increase. So this then becomes an indirect ratio. Now I have to recognize this. First, let's finish setting this up. So how many men as in x in 2 days? Now, the setup for this is a little different, right? But before we can determine how to set this up, we need to recognize, first of all, that this was indirect. So what I'm going to do now is I'm going to now multiply across. So I'm going to say 2 times x, that's x times 2, is equal to 10 times 3, or 3 times 10. In other words, the number of days multiplied by the number of men it will take in those 2 days will be equal to the number of days multiplied by the 10 men for those 3 days. So then again, solving this gives us 15. So x is equal to 30 divided by 2. And so it's going to take 15 men. Again, this should make sense to us, right? Because if we want to work faster, we need more men. And if 10 men took 3 days, and now we want to know what it's going to be to take 2 days, clearly I need more men to finish quicker. This is called indirect, right? So let's try one more. So in 4 weeks, 15 students finished 20 gallons of water. If 5 more students are added to the class, how long will it take them to finish the same quantity of water? Now, very interesting now. Is this direct or is this indirect? So what you have to ask yourself now is, as one increase, does the other one increase? So what we have here is 15 students. And they take 4 weeks. 4 weeks to finish this 20 gallons of water, right? Now, they're not asking us how much water, they're asking us how long it will take, okay? So this is where our x goes. It was 4 weeks. How long will it take for the new amount of students? So first of all, there's more students. So the first question we have to ask ourselves is it going to be a longer period of time? Or is it going to be less time? And logic should tell us it's going to be less time. So I'm increasing the number of students, but I'm decreasing the time it will take to consume all this water. This makes it an indirect ratio. So that's the first hump I have to cross in solving this problem. This thing is indirect. However, that's not the only hump I have to cross. They didn't give me a number of students, right? But they did say 5 more So it's not like this is 5 students, it's 5 more students, right? If it's 5 more students, then it's going to be 15 plus 5, right? So this is going to be kind of like 15 plus 5 more, right? Which really is 20, isn't it? So what I'm looking at now is 20 students. How long will this take for 20 students to finish up, okay? So again, what we're going to do here is we're going to do this multiplication alongside, right? Remember, we worked this out a little differently. So 20 times x is equal to 15 times 4. So 20 times x is equal to 15 times 4. And so x then is equal to 15 times 4 is 60 divided by 20. So x then is equal to 3. And again, if I forgot what I was looking for, I'm looking for how long in terms of weeks. So it will take 3 weeks to be done with that much water if I had 20 students, whereas it would take me 4 weeks when I only had 15 students. Other videos in this and other series are available. Like, share, and subscribe if you found the video helpful. If there's a topic you'd like to see us tackle, just let us know.